Anyone who tells you chemistry is hard has lied to you. Chemistry is not that hard because we give you all of the answers. And we give them to you in a beautiful table, which we call the periodic table of elements. And we're going to give it to you on every test and every quiz. So if you're ever in doubt, reach for your periodic table, because 9 times out of 10, the answer is there waiting for you. So let's do a brief introduction to the periodic table. By no means is this video meant to substitute a lesson on the periodic table. This is just to give you a precursory knowledge, enough to make it through the first couple weeks. So the periodic table is broken up into columns and rows. The columns are called groups or families, and the rows are called periods. Rows lie flat, left to right. Columns stand straight up and down. The periods, the rows, are called periods because there's a pattern that repeats periodically. And in 2 units from now, we will spend a great deal of time on the periods and what patterns are constantly being repeated over and over again. But just know that left to right, the rows are called periods. The columns also go by the name of groups or families, are similar to your families in the fact that families share common names as well as have similar properties. Everyone in my family has red hair. Everyone in your family is probably cooler than me. Elements within the same families can substitute one another in a chemical reaction and get similar results. For example, if I have chlorine, found here, I can substitute it with, say, fluorine or bromine and have similar results. Not identical, and that's not always true, but as a generalization, you can substitute elements in a chemical reaction with other members of its family or group and end up with similar results. So let's talk about some common properties of elements found in different families. There are 5 families you need to know and 1 mob group. So let's talk first about the first family found on the periodic table, group 1A or group 1. Group 1A or group 1 were some of the first elements to be discovered. They were found in salts, and people found that when they put these salts in water, they always ended up with a basic solution. It tasted very bitter. Thus, these became called alkaline metals. Alkaline metals have a very interesting property in the fact that they produce basic solutions, but they also produce hydrogen gas when in their elemental form placed in water. They produce hydrogen gas that explodes because they produce a lot of heat along with that hydrogen gas. So alkaline metals are very interesting to observe when placed in water. They are some of the most reactive elements on the periodic table, and definitely the most reactive metals. Group 2, or group 2A, are called the alkaline earth metals. These also produce basic solutions when placed in water. However, they don't have the explosive personalities of the alkaline metals. When placed in water, they'll pop and fizzle a bit, but you're not going to get a great explosion out of them. They're called alkaline earth metals because they can be found in elemental form in small quantities throughout the crust of the earth. The group that separates the left side from the right side of the periodic table, the mob group as I like to call them, are the transition metals. And while it's true for most elements on the periodic table that you can substitute elements within their own families, the transition metals kind of break this generalization. The transition metals do not display a great deal of the periodicity, the repeating pattern, that the periodic table shows. They do display it, but it's much more convoluted. For example, not every element in the transition metals has similar properties. For example, zinc, found here on your periodic table. Zinc is vital to normal biological functions, is used in DNA replication in small quantities, And I believe it might be used in bone somehow. Maybe. Well, don't quote me on it. I'm not a medical dictionary. But just below zinc is mercury. So while zinc might be vital to life, if I'm remembering correctly, mercury, I know for a fact, is not. Mercury is extraordinarily toxic. So toxic that I'm not really supposed to have any of it at the school. Doesn't mean I don't. But mercury, even small quantities, can cause you to be very, very ill. So those don't have similar properties. The transition metals separate the metals from the nonmetals. So let's talk about some nonmetals. Group 16, or group 6A, are called the chalcogens. Chalcogens get their names from the fact that copper ore typically had oxygen or sulfur in them, because chalcogen means in Greek copper forming. And while it includes the whole group, this group is often usually referred to as the oxygen group because oxygen plays such a vital role in Gen Chem, and we'll do a lot with it. But if you're ever on Jeopardy, Group 6A or Group 16 are called the chalcogens because they were typically found in copper ore. Group 17, though, is a biggie, one that you definitely need to know. Group 17, or 7A, are known as the halogens. Halogens are the most reactive elements on the periodic table, so reactive that all of them, with the exception of one, are never found by themselves. You can never find one atom of fluorine. It will always be fluorine as a molecule, F2. Same with chlorine, bromine, and iodine. Those are all the diatomic, those are not all of them, but that's the lion's share of the diatomic elements that you need to know. Next to the halogens are the group 18, or 8A, the noble gases. These used to be called the inert gases until a couple years ago when scientists, under extreme conditions, made xenon, element right here, react with fluorine to form xenon tetrafluoride. And that was the first time they had ever made a noble gas react with anything else. Noble gases are kind of posh, and they don't like to interact with other elements. And because of that, we were calling them inert, but when we finally made one do it, now we call them the noble gases, because they don't normally react. Noble gases are extraordinarily inert. They separate the halogens, which are extremely reactive, from the, skip back one more, from the alkaline metals. If I'm making you dizzy, don't worry, I'm making myself dizzy too. There we go. So the periodic table can also be broken up into three groups. They can be broken up into metals, nonmetals, and metalloids. Metals, as you move from left to right across the periodic table, elements become less and less metallic until they get all the way over here to the noble gases, where they are nonmetals. What does it mean to be metallic? Well, it means you're malleable, meaning you can be bent or shaped. It means you're ductile, meaning you can be pulled into wires. You conduct electricity, so you're a conductor. And you're shiny. Metals are all shiny. Nonmetals, on the other hand, are the opposite of all of that. They're brittle, meaning they fall apart easily in your hands. When they do form solids, those solids are usually very dull. And they don't conduct electricity at all. Between the metals and the nonmetals are the metalloids. They're kind of metal-like. They're kind of non-metal-like. Metalloids are shiny, but they're brittle, meaning they fall apart. They conduct a little bit of electricity. They're called semiconductors. And that's all I really have to say about them. The periodic table, your best friend in chemistry.